Okay, so this is where we left off. We have a torso rig, we have the leg rig. So this is what the leg is supposed to do. We have additional roll values for the walk cycle and additional side twists. Let's put that back on the ground. And of course we have that for both legs, color coded red and blue. So this is where we left off. Let's have a look at the arm today. So for the arm, I want to go a bit further than what we did for the leg. So leg is currently just an IK, and this is pretty much fine for 95% of our cases. Most of the time the feet interact with the ground. Hence, IK is the chosen method of animating the feet or the leg. You would need FK chains if you have your legs dangling in some way, so basically no ground contact. That would make sense when you have a character that dances and lifts the leg in the air and spins around, or martial arts, or actions like swimming. But for everything else, everything on the ground, normal walking and these kind of things, IK is the better solution anyway. Hence we did it a simplified version. However, what we do for the arm is a FK-IK blend, and that could also be applied to the leg. It's basically the same method done. And for the arm it would look like this. So here we have a setup for an arm, and as you can see here, this is the shoulder. Now basically have three almost identical joint chains. The blue one is the FK joint chain, the yellow one is the IK joint chain, and the purple one is the one that blends between the blue and the yellow one. And the amount of blend, or the influence of the blend, is being driven by this slider here. So when this slider is on FK, the purple will be more to the blue, and when it's on IK, it's more on the yellow side. These joint chains are supposed to be on top of each other, so here this spreading what I did on the shoulder is normally not done. I just did this so it's a bit easier to look at. We also see the color coding here in the outliner. It's pretty much the same color. We can do that in our own setup. I suggest that we do, because it gets cluttered very quickly and it's easy to click on the wrong things or in the wrong order. Hence color coding will help us here. Okay, let's get started. So this is our rig as it is. We have just simply a joint chain up here, and if I rotate this, you see my character is already skinned. Not necessary, but I think it helps to understand how things move. So the first thing we have to do is find this joint here in our setup. As you can see, everything is collapsed. To quickly find something that I have selected in the viewport in the outliner, just hover your mouse over the outliner, then press F on the keyboard, and it will open up the hierarchy to the point where this object is. So here's the left shoulder, here is the left upper arm. We will duplicate this joint chain twice, one for the FK and one for the IK, and everything that's below it. Before we do that, I like to make a group over this one here. So with the left upper arm joint selected, I hit Ctrl G on my keyboard to form a group, and that group I give it a nice name. So left SB for skin bind, arm group, and then that group I duplicate, Control D. Now I have another group here with exact same joints in it. Let's rename this to FK arm group, and let's isolate this one here for now. So with the arm FK arm group selected, hover over your viewport and hit Shift I. So this, what we see here, is the FK arm group. So for this one, and also for the IK arm group, which we will make in a minute, we don't need the fingers. So just delete all the fingers. Be careful not to delete the wrist joint by accident. See, I've just now selected it. So please don't. Rather take your time one by one. We need this joint here. Okay, then with nothing selected, hit Shift I again to leave the isolation mode. This group, the left FK arm group, we duplicate again and we call it the IK group without the one on the end. Okay, so as you can see, it's easy to get confused here already. So let's color code things in the outliner just so we know what we are clicking on. So for example, the skin bind group, we just followed the same color code as we did in as I did in the Neo. So that one I make purple. So with that group selected, go into the attribute editor, and as you can see, there's only one tab because groups do not have any shapes. In here, we go into the display rollout and turn on use outline color, and then you can choose whatever color you want. And I'm also going to do a drawing override, also in the same attribute editor, enable override, and then I choose the same color here on the index slider, so that also the objects in the viewport have the same color. As you can see, it's only visible when you don't have it selected. So whenever you select it, it's unfortunately white again, but you can at least identify it in the outliner. Okay, so the FK group is blue. Same thing, select it, turn on use outliner color, and then choose blue. And I like to use a brighter blue for the outliner color because the darker blue is very dark, it's barely visible. For the 3D view as well, blue color, here it is. And then lastly, the IK arm group, override, choose yellow, enable override, and find yellow. Okay, so that way we can easily identify what group we're working on. Okay, let's start with the FK arm group. I select that one and then hit Shift I in the viewport to isolate it. I turn on the grid. So FK is quite straightforward. It's the same as what we did for the torso. We basically need a control and for each joint, and they are in a hierarchy, and then these controls control the movement or the orientation of those joints via orient constraint. So let's make a circle. That circle needs to be right here on the pivot of that thing. the first joint. And the easiest way is to parent it under that joint. So I select the curve first, second the joint, hit P, and then I select that curve again, reset all the values here by typing in S0. As you can see, it snaps to the joint because it lives in joint space now. In joint space I can rotate it using J as an angle snap, and then just rotate it in 90 degrees. Scale it down a bit. And then unparent it again. Okay. You don't want this to be a child of the joint. It has to live outside. Give it a nice name. We call it left upper arm, or rather left FK upper arm control. Don't forget to freeze the transform. So freeze transform to get nice values here again. It's a good idea probably to leave isolation mode for a moment, just so we can scale the circuit to a reasonable size. So something like this, just so that it doesn't interfere with the torso. Then I select that group and the upper arm group and go back into isolation mode. Next, I make a duplicate and snap it to the next joint. Give it a nice name again, lower arm control. Then again, Control D, V for point snap, and snap it to the next point. And this is wrist control. And we freeze the transform for both of these. This one is already, oh no, it's not, okay. Careful, always make sure that everything has clean values, very, very important. Okay, the wrist is a child of lower arm. So I middle mouse drag it onto the lower arm. Then I middle mouse drag the lower arm onto the upper arm. So this is my hierarchy. Next, I make a constrain, orient constraint for this guy. So I select this control and then shift select that joint. Constrain, orient, option box, maintain offset is what we want. And then we repeat that for this curve and that joint, G. And then this curve and this joint, G. Okay, let's leave the isolation mode. That was the FK. Let's test it. We just rotate this control and it should move the joint chain. Speaking of which, we only want to rotate those controls, okay? That applies for all three. That means we have to lock and hide the translate and scale. Do not lock and hide the visibility for now, because we are going to drive the visibility by an attribute later. So lock and hide only the translate and scale values. In order to parent it onto the torso setup, which we have to do eventually, we need another control in between, and that's the one for the shoulder. So I'm going to make a control similar to the ones that we have here on the torso, basically like a shoulder guard sitting on the shoulder, and then that controls the shoulder. So just starting from scratch with a circle, moving this up somewhere near the shoulder, rotate it a bit, maybe not yet. Let's shape it first into a curve. Move this down a bit. Let's have a look. Something like this. And then we just do the rest in scale. So scale it tighter, scale it up a bit more, move it up more, make it a bit tighter, rotate it maybe a little bit. Okay, so that looks good. So in that position I want it, and let's double check, maybe a little bit backwards. Yeah. So in this position, we need to freeze the transform to get rid of those values. Quite clean. And then I want the pivot to live right here in the center of my shoulder joint. So hold down D and V. So D for pivot mode, V for point snap. And then we snap it right here on that joint. Okay. Give it a nice name. L shoulder control. So the upper arm is going to be a child of the shoulder. And the shoulder is going to be a child of the chest. Okay, so shoulder, shift select chest, and then P on the keyboard. Okay, so that was the FK chain. We are already done with that one. Let's have a look at the IK chain. So I select the IK chain here in the outliner and isolate it. Shift I. So the IK chain is a bit trickier, and this is only because due to the fact how this model is being designed. When we make an IK chain, Maya is looking into the positions of these joints and tries to figure out if there is some sort of plane described in form of a triangle. What I mean with that is if your joints have a visible bend in a direction, like so. Okay, if an elbow is made, or that your 3D model is modeled like this, and you can make a joint chain like this, then there is no doubt for the IK handle solver where the elbow is and which direction it preferably goes. But in our case, unfortunately, this is completely straight. And maybe it's not completely straight because we eyeballed it, remember? So there might be a millimeter offset here, and that's enough for Maya to see a plane here, and that plane might not be what you expect. In my case, for example, when I make an IK handle here, I will create IK handle, rotate plane solver. I click on this joint and then on that joint. See, it's bending downwards. And this is a pure coincidence because I eyeballed the positions of these joints based on my model. And everyone else might have done it in a different way. So to force a certain direction, we can do following. We select the joints and we rotate them in a specific way. Let me undo this. Make sure that you have world coordinate system. Okay, so hold down E and left click it, and then you get this menu here where you can choose between object mode and world. So choose world and then rotate the joints in world mode. So now we're describing a perfect flat plane in X and Z. And to save this in the joints for Maya to process this, we just basically select both of these joints, right click it, and then set preferred angle. That's it. Now we have to rotate these joints back to their original value, which is basically rotation value 0. So this one and that one. Okay, so now they're perfectly straight. But if I make an IK handle now, see where this pole vector is pointing? Now it is going to this preferred angle, which is perfectly horizontal. That's what we need. So this might be an issue you encounter, especially with this character. But in other characters, again, you might encounter this even with legs. When the legs are perfectly straight, you might need to set a preferred angle before you continue creating an IK handle. That saves you a lot of trouble. Okay, so we have this. Now we want to control the IK handles by using controllers, of course. For this one, I'm going to leave the isolation mode because I want to use the hand, the shape of the hand, as like a guidance to trace and draw a hand controller that has the shape of a hand. So I'm looking from the top view onto the hand, choose my curve, my EP curve tool, and I switch it to 3 cubic. Just start here somewhere, and then I draw out the curve. And it doesn't have to be perfect at first. We can always edit those points later. Something like that. And then hit enter when you're done. And I right click that curve, control vertex, so I can edit those. Control vertex there. So I can edit those points a little bit and change the shape a bit more. Move this inwards. So you want that shape to be slightly bigger than your hand, so it's easy to select also from far distance, okay? Because you don't want the animator to have to zoom in every time. I switch to perspective mode, and you see the drawing is on the ground plane. Of course, let's move it upwards. First, I center the pivot, which is currently in origin, and then I move this up. And I hold down V while I'm moving up, and then I snap to my wrist joint. So it's perfectly aligned to the wrist joint. Then I want the pivot to be also right here in the wrist joint. So D and V to snap the pivot to the wrist joint. Lastly, freeze the transform. So this is our hand control, or we call it the left IK wrist control. And we need another one for the elbow, the pole vector, just similar to the knee, and because it's so similar, that's why we also steal the control. No need to make it again. So that control selected, Control D. I move it up, the duplicate. I hold down V while moving it up. So I'm snapping it to my elbow. Move it a little bit backwards. Rotate it, holding down J. So I snap in 15-degree angle. Then I unparent this because it's currently part of the leg setup. That's not what I want. Here it is, outside of my setup. And now I can rename this. Elbow pole control. Don't forget to freeze the transform. So the hand control, or the wrist control rather, is going to control the position of our IK handle. So I'll select my control and then shift select my IK. And then I'm going to make a point constraint. And we don't need to have maintain offset turned on because they are basically on top of each other. This one here is controlling the IK handle's pole vector. And so 1 second, I just see I have the old IK handle still in here, so let me delete that one. Okay, so this one controls that IK handle's pole vector. So let's test it. If I move it, it moves the IK handle. If I move this, that moves the elbow. But as you can see, the orientation of the wrist is still not quite there, right? It's supposed to do exactly what my hand does. So let's undo all that. That means we have to make an orientation constraint between this control and the yellow wrist joint. Make sure that this is the correct one. And then constrain orient with more offset, because the orientation of my hand control and the one of the wrist is not identical, or might be, but there's no guarantee for it. Just maintain the offset and you're good. So let's test this. When we rotate our hand, that joint is also rotating. Okay, that was our IK setup. Now let's do a bit of house cleaning. So this wrist control is currently just living in space. Let's make it for now a child of the root control. So I select that one, shift select the root control and hit P. So now it's part of that. The elbow, I like to connect or make that a child of the shoulder. So I select that one and shift select the shoulder control and then hit P. The IK handle is currently just sitting here and it doesn't have a group, it doesn't have a special name. Let's give it a nice name so we can easily identify it. This is the left arm IK handle. And we drop it into the MISC group, which currently is under Do Not Touch group. So just middle mouse drag it in here, where it lives with the other things that the animator is not supposed to touch. Let's talk about the colors. Currently everything is yellow. That is because when it is a child of something that has a color, then it will inherit that color. So it trickles down from the root control all the way to the hand. But we can do another override here on the shoulder. So we just go in the attribute editor on the left tab into the display section, drawing override, and then enable an override here and change the color to red. So everything that is parented under the shoulder control will turn red. The hand itself is not red because it's parented under the root directly, so let's make that one red as well. Okay, what's next? The influence of the IK handle. Let's move it over here. And the FK join chain onto our purple skin bind join chain. Because as you can see right now, it's not doing anything, it's just straight. Now this is rather simple. Basically, we select two parents and then one child. So two controllers, screwdrivers, can control one object via orient constraint in this case. So I would suggest that we always select them in the same way. Means you start with blue, shift select the yellow one, and then lastly the purple. Okay, blue, yellow, purple, in that order. FK, IK, and skin bind. Then we make a orient constraint on that. We don't need to maintain offset. And you have seen it moved a little bit. Let's repeat the process for the lower arm. Blue, yellow, purple. Constrain, orient. Repeat the process for the wrist. Blue, yellow, purple. Constrain, orient. So if we move the yellow one, the purple should move. But also if I move the blue one, the purple should move. And as you can see, it's 50%. So there's a bit of half of the influence comes from the IK and half of the influence comes from the FK chain. Now normally you don't want that. Usually you want either IK or FK. But you want also in between values when you transition between them. Otherwise you will have a pop in your arm. So we have constraints, 3 constraints now. Let's find them. First we select that purple upper arm and then hit F. Or let's select the wrist rather, the purple wrist, and then hit F on the outliner. So here's the wrist. See, it's the purple chain. And when you open the wrist joint, you see all of these 3 orient constraints that are currently looking like this in the channel box. W0 and W1. So that's weight 0 and that's weight 1. And both are currently set to 1. But if you set 1 to 0, Sorry, that was the wrong one. This one. You see the second input has 100% influence, which is the IK chain. Now the purple joint is on top of the yellow one. And when I slowly increase that value here, it goes more and more to the blue. So these two values we need to control, and that is done via a slider. But we are not going to make a slider like the one in Neo. We make a slider on top of a control as like an additional attribute for several reasons, which I will explain in the class. But they're mostly cluttering, really. Things get cluttered here very quickly, so we want to have stuff that is not as hard to reach. Sliders are a bit hard to reach, hence it's better to have a control that you just select and then you use the channel box for editing things. Okay, let's make a control for that. I'm just putting in the grid again so I can easily snap to the grid. I'm choosing my EP curve again, and this time back to one linear. Hold down X, and I'm drawing a simple plus cross. The pivot is not in the center, so let's click on center pivot. We scale this thing down, we rotate it by 90 degrees, then we move it somewhere to the shoulder, move it a bit behind, a bit up. Let's hide the grid. So I want this to be somewhat slightly offset behind the body, but visibly belonging to the left-hand side of the character, okay? Because we will have another one on the other side. So it has to be clear that this is controlling the left-hand side. Okay, so there, we leave it. So freeze transform. And I make this guy also a child of the shoulder. So select the shoulder as well, and then P. This control cannot move or rotate or scale, so we will hide all of the channels, including the visibility, and lock and hide. Then we make an attribute for this, a new attribute via channel edit menu, add attribute. The type of attribute is enum, sorry, not enum, float, and it's a FK with a capital K, F, and then a small k, capital I, K, so FK, IK, capital B, blend. Okay, so camel casing means basically having capital letters in between. Creates spaces in the channel box. Okay, so the value goes from 0 to 1, and here you always can see already in slightly gray what the final name will look like. So the camel casing puts spaces in between. Nice name is with spaces. Then okay. So this value can go from 0 to 1, and that drives our IK blend. To set up this IK blend, we need the node editor. We find that in Windows. Let me make this a bit smaller. Okay, here we go. Okay, so we need a handful of objects. We need the slider, and we need to select the 3 orient constraints. Okay, so the slider is the plus here, and then these 3 orient constraints. and then we load those into the node editor. We have also the shape. We don't need that one. We just need the curve itself. And we haven't named it, it seems, so let's do that quickly. Where is it? Here, curve. Yeah, curve is not a good name. So L F K I K switch control. LFKIK switch control. Okay, that's better. So here's our LFKIK switch control, and these are our orient constraints. So what we basically have to do is, when we want FK, then this value should be 0. So 0 means FK, 1 means IK. When it's 0, then we want this value to be 1 and this value to be 0. Okay, so that one was our first one that we selected. That's the IFK, and that is the second one we selected when we made the constraint, that yellow one, and that is the IK. So we want the second value, W1, to be 0, basically the same value that we have here in that slider. So this slider value goes straight into W1, like so. For all of them, because we did all of them in the same order. So that is the reason why I asked you guys to do that in the same order every time. Otherwise you have to figure out which value you have to go into. Now we need to do the same but reverse for the other value. So basically when this is 0, then this needs to be 1, right? And vice versa. So how do you make a value that is 0 into a 1? And that's quite simple. You use a float math node, so hit tab in the node editor to get this text field, and then type in float, and there is the float math node. So the float math node has 2 inputs and 1 output, and it does something with these 2 values. Right, so you go in the attribute editor and then you see what it does. It takes basically the first value and the second values and adds them. But we can change that to subtract. And what we are going to do is 1 minus whatever that slider gives us. So this slider value goes in float B. So see, this is currently 0. 1 minus 0 is 1. So when this value is 0, then this one is 1. So the reverse. So the out goes into W0 for all of them. There you have it. Let's name this node here 1 minus B. So this is what this here is, 1 minus B. Okay, let's have a look if that works. We select this control, and in the channel box we have this value, and I just select the label and then middle mouse drag while holding down control to have a bit of finer control. And here you go. You can just blend between FK and IK. Okay, that works. Now, you don't want to see all of these controls at the same time, right? So if you are animating in FK, then you don't want to see the IK controls, and vice versa. So it would be nice to also control the visibility of these controls via that slider here, and that's quite easy too. So we basically select the curves, the controller curves that we want to control. So this guy here, the elbow one, and this ring here. We don't need to select all of these rings, just that one, because these ones inherit the visibility from that one, so they will disappear as well. Back into our node editor. Make it a bit bigger. So with that selected, I just add those things, and we just need a transform, so I'm moving them over here. I hide those shape objects by clicking on this minus. Okay, so we have the FK here and these two IK objects. So this is the IK wrist and this is the elbow pole, this is also IK. So basically, when the switch is 0, we want to see the FK control. That means the visibility should be 1, which is the reverse, which we get from here. So that one goes into visibility. And that means this one's visibility, this one's output value goes into the IK visibility, because that's the reverse. Right? So when this is visible, then this is not visible. When this is visible, then this is not visible. So the reverse, let's spread this out a bit. Okay. So let's test it. Select that control, and in IK mode, the IK controls are visible and the FK are not, and in FK mode, 0, the FK controls are visible and the IK controls are gone. Just like that. So let's hide this guy, and we select all these controls and 0 them out to get them back to rest position. The same for these guys, 0. That one is already 0. So we are basically done. Now one thing I would like to do, I'm just looking if I need to clean out here, but it looks all good. One thing I would like to do is have a bit of a control of this hand's reaction space. So currently this is parented under the root control, and that will make this hand stay put wherever it is in space relative to the root control. That means when I move my hip, you can see that hand control stays put. But when I move the root control, it doesn't. Okay, because it is in root space. But sometimes you want that hand to be in multiple spaces, in different spaces, not just in root space, but also in hip space, for example, or in chest space, or even in head space. Like when you put your hand on the head and then you move the head, you want the hand to stick to the head, right, or stick to the hip. So it would be nice to have some sort of space switch, and that's rather easy to do in Maya. First, let's find that hand. Okay, currently parented under the root, so if I hover over the outliner and hit F, I see my wrist control here. So let's unparent that for now. And then we put this in a group. Why? Because when you want to make a constraint between an object that you actually still want to be able to move around manually, you just put it in a group and constrain it, rather the group to the things. Because once it's constrained, you can't move it anymore. But you can constrain the group and then you still move the hand inside of the group. Okay? So the group, which we call left IK wrist control con group for constraints. Okay, so this one will be constrained to multiple objects at the same time as multiple driver objects. And we select them in a specific order. So root first, then shift select the hip, shift select the chest, shift select the head, and then control select that group last. Okay? So we have 5 objects selected at the moment, and the last one is the group. And then we make a parent constraint with maintain offset. That gives us a constraint that has these 4 values here. One is the root, hip, spine, that is our chest here, and head. And currently they're all weighted with 1. That means basically 25%. So equal share of 100% weighting is being distributed to all of these parents. So all of them influence the position of my hand at the same time. Not what I want usually. Usually I want one value to be 1 and the rest to be 0. Okay? Something like this. Now it is completely influenced by the root control, but not by the hip and spine and head anymore. So it would be nice to have an interface for this on the hand usually. So we can add a attribute here on the hand that lets us choose in what space we are currently being constrained to. Let's call this parent space. It's going to be an enum. Enum is a list of words which return values though. So green will be renamed to root. Blue will be renamed to hip. We do it in the same order as we selected the objects before we constrained them. The last one, the next one is chest, and then the fourth one is the head. So root, hip, chest, and head. Click OK, and it gives us this pull-down menu. So now we can just switch like that. But it doesn't do anything at the moment. So we have to build up the logic for this. So with this control selected and that parent constraint selected, both, I open up the editor again. And it seems like they're already there. So we have a shape again we don't need. We have a group, we don't need that either. But we might need this one here. The constraint, yep, that's the one that we need. And we need this here. So I move this a little bit to the side. So this one has the parent space value. The parent space value is driving these input and output values, the weight values. There's some strange connections here that I really don't appreciate for visibility. Okay, so the way of doing this is this. This value here returns a value of 0, 1, 2, and 3. So when I choose hip, I'm getting a value of 1. If I choose root, I'm getting a value of 0. Now this needs to be interpreted into a matrix of values, like 1, and then 0, 0, 0, or 0, 1, 0, 0, or 0, 0, 1, 0. So this kind of matrix, okay? And this is best done with using a float condition node, float condition, okay? And when you look into the attribute editor of the float condition, you can, that's not the right node, I think. So float logic, that's the one that I was looking for. Okay, float logic. So when you look at that attribute editor, you see it basically compares two values, and if they are equal, so this means equal, then we get a 1 from that back. Otherwise we get a 0. Okay, so true or false. Is it equal? Then yes. If it's not, then no. Okay, so basically the parent space goes into float A, and it compares it with the second value. Is it equal 1? If yes, that means it's root. So let me put that in here, equal 1. Okay, so I duplicate that. Equal to, already renamed correctly. That's nice. So is it equal to? Again, we take the same value, the parent space value, go in float A. If it's true, if it's 2, then set W1 to 1. Duplicate that one. Equal 3. Float A is equal 3. Then, if that's true, set W3 to 1. And if it's equal 4, oh, actually, this is actually 0, because the first value is actually 0. The second one is 1. That was my bad. So that one needs to be compared with 0. This one compared with 1. This compared with 2. And this one lastly with 3. And then if it's true, if it's 3, then this will control. Oh, I must have mixed something up here. Yeah, this needs to go to that one, and that one. This one. So as you can see, Maya doesn't necessarily sort them proper. So it's like W3, W1, W0, and W2. So it's a bit mixed up, and that's why all that crisscrosses. That's I would say a bug in the software. It's not very clever. But anyway, so this one here compares with 0, this compares with 1, this compares with 2, and this compares with 3. So if this one delivers a 3, which is head, and this one turns into a 1 and everything else into a 0. And just like that, you see these values here changing. Okay? Now head is 1 and the rest is 0. So switch it back to root and then we can test it. So that's the setup. Now this thing needs to live in the controls group, but it doesn't need to be a child of the root control anymore, so just drag it into the controls group because it's already constrained to the root control. Okay, I think that's enough. We do the lower arm twist joins and the hand rig in the next video.